students, to the review sheet part 2. We did number 72, and we are going to start off with number 76. And here we go. You have a home mortgage of $85,000 with an interest rate of 11%, and your loan is good for 20 years. What is your monthly payment, and what is the total interest paid? Now, by the way, on the test, you're allowed to have this formula written down if you want to, okay? I have no problem with that. And here we go. First of all, let's find what I equals. Remember, I is always your interest rate times 1/12, or in other words, your interest rate, 0.11, divided by 12. Now, if you type this into your calculator, you're going to get out 0.00916 repeating. So I equals 0.00916 repeating. Alright, so I'm going to use 0.00917. So for my I right up here, I'm going to use 0.00917. Now, think about it for a second, students. For I right here, if you put 0.00917, then add 1 to that, you'll get 1.00917, okay? So I'm just going to get my eraser out and make a little bit of space here. And here we go. So I would have 1.00917. Now with your calculator, if you type in 1 divided by 1.00917, divided by 1.00917, and hit enter, and then raise that to the 240th power. This entire expression right here becomes, it'd be 1 minus 0.11830539. I'll probably round that to 1183. So this entire denominator now becomes this right here, 1 minus this. And of course, 1 minus this is going to be 0.88817. So with your calculator, simply take 0.00917 divided by 0.88817, enter, and then right here where your P is, we should have 85,000. So multiply that times 85,000, and you should get the correct amount, which is $877.59. So there's your monthly payment, $877.59 approximately. Okay, now that's the first thing they want us to answer. What is the monthly payment? So there's your monthly payment. Okay, now they want us to find the total interest paid. Well, think about this for a second. You're making this payment every month for 20 years. Well, there's 12 months in a year, so 12 times 20 is 240. So now take your monthly payment times 240, because that's how many times you're going to make that payment, okay? And you're going to see you're going to pay this much money, $210,621.84. So how much did you borrow? 85,000. How much did you pay back? This much. So subtract 85,000, and your total interest is $125,000. $125,621.84. So you borrowed this much money, you paid back this much money, and there's the extra that you paid, or in other words, the interest. Alright, moving on to number 77. Okay, 78. Now this one's pretty confusing, but if you'll listen, I'll be able to walk you through this and help you, okay? For the worm and wheel gears shown to the right, you can look in your book and see that the distance d on the perimeter of the wheel that the wheel gear rotates varies jointly. So d varies jointly this down. N is the number of threads, number n threads. So n is the number of threads. Number of threads. Got it? Now, remember, the first thing we have to do is solve for k. There's no way we can even come close to solving this problem unless we first find what k is so we can get a working model here. So a wheel gear whose teeth are 0.8 centimeters apart. So teeth are this far apart. Well, that's p. P is the distance between each tooth. So p would be 0.8. Alright. A wheel gear whose teeth are 0.8 apart rotates 4 centimeters. D is the distance of rotation. So D would be 4. Bring down your K. And it has 5 threads on the worm gear. And N is your number of threads, so 5. So we have 4 equals 0.8 times 5 is 4. So we have 4K. Divide both sides by 4. And 1 equals K. So now I know what K equals. K equals 1. So right here where K is, I can put a 1 there. Now, how far would a wheel gear, whose teeth are so far apart, rotate? Now watch this. How far would the wheel gear rotate? How far would a wheel gear whose teeth are so far apart rotate? So we're looking for how far the gear is going to rotate. Which one of these deals with distance of rotation? D, so I'm looking for D. Okay. Now, the teeth, whose teeth are 0.5 centimeters apart, which one is the distance between each teeth? P. So P is 0.5. Number of threads, 4 threads, N, number of threads. So the answer would be 1 times 0.5 times 4, which is 2 centimeters. And that's it. Moving on to number 79. Now 79 is on the review sheet. After looking at it, it's not that hard of a problem, but I am not going to work this out. And we are not going to do it dealing with all these scientific notations. Okay? It's a great problem, but there's no way I'm trying to test your ability to write direct or inverse or joint variation equations and then solve them, not, use a bunch of scientific notation numbers. So we're going to move on. Okay, number 12 on page 521. Number 12 on page 521. The directions say to find the domain. Okay, so whenever I ask you to find the range, you're going to tell me what y is allowed to be. Whenever I ask you to find the domain, I'm asking you what x is allowed to be. Okay, well look, we have a rational expression. We know this denominator cannot equal 0, so when I'm asking you what can x be, I'm first of all going to find out what x cannot be. So I'm taking my denominator and setting it equal to 0. Alright, now you're welcome to use the quadratic formula, but I'm going to factor. I've got a trinomial. This power here is twice as big as this power here. I have a lead coefficient of 1, so all this is pretty easy. So what two numbers when multiplied together give me a negative 12? When add together give me a negative 4. That's going to be negative 6 and positive 2. When I multiply those, I get negative 12. When I combine them, I get a negative 4. Now, if I take this parenthesis, set it equal to 0 and solve, I get 6. Take this parenthesis, set it equal to 0 and solve, I get negative 2. So x cannot be these two numbers here, because if I put 6 in for x, I will get a 0 in the denominator. If I put negative 2 in for x, I will get 0 in the denominator. So those are the two values that x cannot be. I really see no other problems up here, so really x can be anything else. So here's how you write your domain. You would write all real numbers, comma, such that x cannot equal 6 and negative 2. Now a lot of you on your last quiz, on other quizzes, just put this for your answer, 6 and negative 2. And I counted that wrong. You're basically telling me that x can be these two numbers. I'm asking you to tell me what x can be. Well, x is all real numbers except for these two numbers. numbers. It cannot be these two numbers here. All right. Okay, number 15 or number 35 on page 115. So we're going way back now to chapter 2, I believe. And it says to x and y vary directly, find an equation that relates them. So x and y vary directly, so you know the model you should use. And now let's solve for k. So where the y is, I'll put a 10. Where the x is, I will put a 1. Okay? And now divide both sides by 1. 10 equals k. So where the k is, I'm going to put a 10. And that's my answer. There's my equation that relates x and y. Y varies directly with x. Okay? And there we go. Alright, moving on to numbers 64 through 67, page 117. Here we go. Now, first of all, above number 64 in your book, you'll read it says, while at rest, a person inhales about 12.5 liters of oxygen every minute, but their body only absorbs about 0.5 liters, okay, by the blood system. Through the person's lungs, the rest is dispelled when the person exhales, so you breathe in 12.5 liters, but you're only keeping about a half a liter. Now look at the last sentence above number 64. The last sentence above number 64, it says A varies directly with I. Let's write that down, okay? A varies directly with I. Now let's read what A is. A is the amount of oxygen A is the amount of oxygen that you use. Okay? That's an S. I should do that again, shouldn't I? A is the amount of oxygen that you use. I is the amount of oxygen that you inhale. So this is going to be bigger than this because you inhale a lot and you only use part of it, okay? So here we go. Write an equation that relates these two. Okay, well, let's go back up. You say, well, Mr. Arrett, we can't do that. We have to solve for k. Well, yeah, but go back up to the part above number 64. It tells you that you inhale 12.5 liters and you only keep 0.5. All right? Now divide both sides by 12.5 and you're going to get 0.04 for k. So now I can substitute 0.04 in for k. So here's my new model. A equals 0.04I. So there's my answer to number 64. Okay? Alright, let's erase this. And let's continue on. We're probably going to need this. And by the way, 0.04 is the same thing as 1 over 25. Alright, let's copy that in case we need that later. Which we probably will. Okay, number 65. The maximum amount of oxygen that a person's body is capable of using is about 3.5 liters per minute. That's a lot of oxygen. And this would normally occur when a person is doing heavy exercise. Something I probably know very little about. But anyways, at this rate, how much oxygen would you be inhaling? So let's take our model, okay? Now think about this. Are they giving you the amount of oxygen you're inhaling? Or are they giving you the amount of oxygen you're going to use? Well, it says a person's body is capable of using this much. So that's how much you're using. And then not only did it say that, it even says how much oxygen would be inhaled. Okay? So we're looking for I. So they tell us how much oxygen we're going to use. And they ask us how much we're going to inhale. So we're going to divide both sides by 0.04. And if we take 3.5 divided by 0.04, we're going to get 87.5. Alright, which is the correct answer. I've already checked that. 87.5 liters is how much you inhaled in 1 minute to get 3.5 liters of oxygen that you're going to use. Alright, number 66 now. How much oxygen does your body absorb in a normal day? So we're not talking about exercising a normal day. Alright, well guys, this is really, really, really easy. Go back up to the information above number 64. It tells you, now, first of all, it says absorb, okay? So it does not ask how much oxygen do you absorbing 0.5 liters every what? Every minute. Got it. So how many minutes are in a day? Well, there's 24 hours in a day, right? And every hour has 60 minutes. So I'm going to take 24 times 60. That's going to give me 1,440. So we're just about done. Think about it, guys. In one day, you have this many minutes. And every minute you need 0.5 liters. So simply take 1,440 times 0.0 times 0.5 and you will get 720. Okay? So that's how much liters of oxygen you use every day. Now this next problem we're going to do, I kind of disagree with their answer, but I'm not going to get too nitpicky, okay? It's almost like they're comparing apples with oranges, okay? But let me go ahead and walk you through this, okay? 1 square foot of plant surface produces about 0.1 liters of oxygen per minute. So if I have 1 square foot, if I have 1 square feet of plants, that's going to give me about 0.1 liters of oxygen. Now, notice it says during photosynthesis, okay? So during photosynthesis, this is how much oxygen you get out of a square foot of plants. But you get 0.1 liters. Now, photosynthesis only occurs during sunlight, during daylight, okay? Got that? Now, down here it says, assume a normal day has 12 hours of sunlight. So, hold on a second. Stop and think, okay? 1 square foot of plant surface produces about this much liters of oxygen per minute. So this is per minute. I should put per minute. Okay? So in 1 minute, your square foot of plants will give you that much oxygen. But guys, students, men, ladies, dudes, that's only for half a day. Because the other 12 hours is not getting sunlight. So really, I'm going to cut this in half. Mr. Hart, why are you doing that? Well, I'm going to tell you why. Because their question is, how much plant surface do you need to replenish your body, to replenish the oxygen your body uses in 24 hours? So you're using oxygen for 24 hours. That's twice as much as 12. Think about it, guys. Come on. Only for 12 hours a day am I getting this many liters per minute from a square foot of plants. Like, here's a little square foot, a foot by a foot by a foot by a foot. And it's all filled up with plants and trees, okay? That 1 foot by 1 foot square, as long as the sunlight is shining on it, is giving you 0.1 liters of oxygen per minute, okay? But that's only for 12 hours. So really over the course of 24 hours, that's cut in half, it really is. And since I'm trying to compare how much oxygen I take to how much the plant produces in 24 hours, I really have to say this. 1 square foot only gives me, let's see here, 0.1 divided by 2, 0.05. I only get 0.05 liters of oxygen per minute. I've got to cut that in half because it's only working for half a day. So even though it gives me this much every minute, after 12 hours it stops, and so I'm not getting anything else for the next 12 hours. So really, I took 0.1 and divided it by 2. I cut it in half. So 0.1 divided by 2. Type it into your calculator if you want to. Will give you 0.05 liters per minute. So this is the more accurate. This is the ratio I need to use, or the conversion factor I want to use. I am going to use ratios, by the way. I'm going to say this. I'm going to say 1 square foot gives me 0.05 liters per minute. Alright? Like that. Now, students, let's think about this. I'm looking for, here it is, approximate the number of square feet of plant surface. So I'm looking for square feet. I'm looking for how many square footage of plant surface do I need. So I'm going to put an X here because that's what my square footage is. And look, how much square footage do you need to replenish the oxygen that your body, keyword, absorbs in 24 hours? Alright? How much does your body absorb in 24 hours? Now, students, So a lot of you want to take the amount that you absorb, go back to that paragraph above number 64, and it says your body absorbs 0.5 liters per minute. So a lot of you want to multiply that by 24, which is fine, but there's really no need to, because we're not multiplying this by 24 either. We're comparing liters per minute with liters per minute. So if I'm losing this much here, liters per minute, which I am, then over here I need how many liters per minute? I need 0.5, right? That's what it says. If you look at the paragraph above number 64, it says every minute you absorb 0.5 liters of oxygen. So 0.5 liters per minute. So cross multiply 0.05 times x. 0.05x equals 1 times 0.5 is 0.5. Divide both sides by 0.05 and you will get 10. You will get 10. And of course that's x equals 10. That's square feet. So in one day you need about 10 square feet of plant surface to provide you with the oxygen that you need. Okay? Alright, moving on. Number 39 on page, look at my review sheet here, page 538, number 39. Okay, students, the directions say to simplify. So I'm going to divide two fractions. And then whatever I get, I'm going to multiply that times this fraction. So what I've taught you, you don't need to get a common denominator because we're not dealing with adding or subtracting, but I have taught you to factor as much as you can. So my numerator here can be factored. Pull out an x and you're left with x plus 11. The denominator stays the same. You cannot factor x negative 2. Now it says divided, right? I'm going to make it multiply. And I'm going to flip this fraction so the 1's up top now. And down here I'm going to factor this. I can plot a 3 and an x, because 3 goes into 3 and 6, and there's at least one x in both of these. So there we go. There's the denominator. Alright, now let's put times. And now we can factor this top parenthesis, this top fraction here. We have the difference of two squares. We should know how to do that very quickly by now. X positive 2, x negative 2. All over x positive 11. Now I have worked these problems out ahead of time, so I'm going to look at my notes to make sure I'm not making any little mistakes, which is pretty easy to do. I want to be careful. Now I've got x plus 11 canceling diagonally way over here. I've got x negative 2 canceling diagonally way over here. I have x positive 2 canceling diagonally with this. I'm left with nothing here. 1. Nothing here. 1. Nothing here. 1. Now I have a monomial and a monomial. I can reduce those. So I have an x here and an x here. So cross off your x. You're left with nothing here, so I'll put a 1. Nothing here, so I'll put a 1. Cross off your x and you're left with 3. So 1 times 1 times 1 is 1. 1 times 3 times 1 is 3. 1/3. So the main thing you wanted to learn here was don't forget to flip your fraction and multiply. And don't forget to factor as much as you can so that you can simplify the fraction, the problem, the answer. Okay, number 40 on the same page, we are going to the same thing. We're going to simplify completely. So now here we have to do inside the brackets first. Okay, so let's go ahead and work on this first right here. Let me look at my worksheet here and make sure I have this worked out already ahead of time. I've got pieces of paper and notes all over the place. Okay, here it is right here. Alright, now I'm going to forget about this part of the problem right here for a second. We'll worry about that later. Right now I'm going to work on these two fractions. So my numerator can be factored into x positive 4, x negative 2. This, I can pull out an x over here, so pull out an x and you're left with x plus 15. My denominator stays the same, x positive 4, and my denominator stays the same, x negative 2. I'm going to multiply these two fractions together. So I can diagonally cancel. I can vertically reduce. So 1 times all of this will just simply be x parentheses x positive 15 all over what? All over 1. 1 times 1. So I multiplied these two fractions together right here. And I got this. Okay, 1 is 1, 1 times 1 is 1, 1 over 1 is 1. Okay, and that's the answer. All right, moving on to number 22 on page 545. And the directions say to find the zeros of the function, okay? Now remember what I've said. I've taught you guys this. Anytime you're trying to find the zeros of a function, that means you're finding the what? Do you remember? Finding zeros means you're finding the x-intercepts. I've also taught you how to find the x-intercepts of a rational expression. Do you remember? You always take the numerator, not the denominator, the numerator, and set it equal to 0 and solve. And that will give you the zeros or the x-intercepts. So here we go. Take your numerator, set it equal to 0 and solve. I can factor this. And as you can tell more and more, I'm just going to go through the factoring quickly. I'm not going to keep teaching you guys how to do this. We've had plenty of time to learn this. So x negative 7, x positive 3. Alright. Take this group, set it equal to 0 and solve. You get a 7. Take this group, set it equal to 0 and solve. And you get this. So there you go. We're finished. That's it. Done. That's simple. When I ask you to find the zeros of a rational expression, that means you're looking for the x-intercepts. And you find the x-intercepts or the zeros by taking the numerator, setting it equal to 0, and solving. Alright. Okay, moving on to page 546, we're going to look at number 48. We're going to solve a rational equation, okay? Let me look at my notes here and find where I've got that done already. I don't want to make any mistakes. And by the way, when I worked these last two problems out, I did make mistakes. I had to go back until I had it perfect, so it's easy to make little mistakes on these. Okay. Alright, first of all, we're going to be, if we're solving a rational equation, we want to multiply everything by a common denominator to get rid of our fractions. So the only way to find a common denominator is to factor when you have to factor. When you're able to factor. So I cannot factor this binomial here. I cannot factor this one. However, I can factor this one. I'm not going to take time to do that for you. But it's kind of funny. You get 4x negative 1, which is what I have here, and x positive 3, which is what I have here. And again, guys, I'm not being moved by now. I've taught factoring, I think, months ago, okay, at this point in time. And I warned you then, it is your job to know how to factor, okay? So if you factor this trinomial right here, you'll get this right here. So let's find our common denominator that we're going to multiply this entire fraction by, okay, this entire equation by. I have a 4x minus 1 here, and I have 1 here, and I have none here. So I need one of those. Compare binomials with binomials. I have an x plus 3 here, one group. I have one group here, I have none here, so the most I have is 1. So I'm going to take this phrase here, this expression here, and I'm going to multiply it by everything in this equation. Shrink it down and get some room to work here. Okay, I'm going to multiply this entire equation by this expression here. Alright, so let's see what happens. Here we go. First of all, 4x minus 1 would cancel with 4x minus 1, leaving you with this times this. Alright, so I have x positive 3 times 13x plus 16. And then a positive sign. And then this entire expression here is factored. It's this. So this would cancel with this, leaving you with the numerator. Positive 8x squared, positive 12x, positive 14 equals, now we multiply this times this. Your x plus 3 cancels with your x plus 3, leaving you with 4x negative 1 times 24x minus 8. Now I know I could have factored that right here, but I'm really not too worried about doing that. Remember, when solving rational equations, your goal is to find a common denominator, and when you're finding a common denominator, you must factor the denominators as far as you can. I'm not really worried about the numerators in problems like this, okay? Now, let me get a drink here. Let's simplify this as far as we can, okay? We have x plus 3 times 13x plus 16. If you multiply this binomial times this binomial, you will get 13x squared, positive 55x. By now we should know how to do this, guys, okay? this positive sign here. When you multiply through the parentheses, nothing changes, so your 8 stays positive, your 12 stays positive, and your 14 stays positive, okay? Now when you take 4x negative 1 times 24x negative 8, you end up getting, let me check my notes here, 96x squared minus 56x positive 8. So right away I see I have a quadratic equation. How do I know that? Because my highest power is a 2. So I know I want to get one side equal to 0, okay? First of all, let's simplify. I've got a 13x squared and an 8x squared. Combine those, 21x squared, 55x, 12x, that's 67x. And then positive 48, positive 14, positive 62 equals, and then we'll bring this down right here. Now, let's get one side equal to 0. Bring this over and make it a negative 96x squared. And we're going to be left with, actually, you know what I'm going to do? Hold on a second. I did realize this when I was making my notes. I got thinking, remember how you always want your first term to be positive when you're factoring? There's a good chance we're going to be able to factor this now. You can bring the 96x squared over and make it negative. But that's going to give you a negative 75x squared. And then you're going to have to factor out a negative 1 to make that positive. We talked about this. When you guys learned how to factor, you never want your first term to be negative, so you always factor out a negative sign. I would rather just bring the 21x over, x squared over myself, so that my first term is positive. That's what I'm going to do. So I'm going to bring it over and make it negative, and I'm left with positive 75x squared. Bring the 67 over, make it negative 67. And that's going to give me negative 113. And we're going to end up not factoring anyway, so it doesn't matter. Bring the 62 over, make it negative 62. That's going to give you a negative 54. Let me check my notes to make sure everything is accurate so far. Okay, there's one mistake just like that. It should be 123. It's really easy to make those little mistakes on your test, so really be careful, okay? Okay, moving on. Everything else looks good. So I've got this entire mess right here, simplified all the way down to this right here. Okay, so let's go ahead and clear off the screen here and get some room to work. Now, you can factor this, and feel free to if you want to. And I'm usually a very big fan of factoring. However, in this case, because you're going to have to take 75 times negative 54, then try to find factors for that number, that's going to be really tough to do. So in situations like this, I'm going to use the quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. So here we go. This is my a, b, c. So it's a negative sign. I'm putting in a negative number, so I get a positive 123. Square root of, when you square 123, you get 15,129. And then negative 4. And then when you multiply a times c, you're going to get 4,050. Just like that. Now, with your calculator, don't forget to do your multiplication first, okay? If you did, you get negative 4,050. Sorry about that. Negative 4,050. So a negative 4 times a negative 4,050 gives you a positive number plus 15. Oh, you know what? I should do 2a real quick. All over 2a. A is 75. 2 times 75, 150. Now, back to where I was at a second ago. If you take negative 4 times negative 4,050, you get a positive number. Add that to 15,129, and you will get 31,329. And I'm hoping that's a perfect square, and it is a perfect square, by the way. All over 150, okay? So with my calculator, I typed in the square root of 31,329, and it is a perfect square. I got this out. I'll put it right up here. I got 123. It's 177, so plus minus 177 all over 150. So now I'm going to write this two different ways, okay? I've got 123 plus 177. That's 300 over 150. And then 123 minus 177. That's negative 54 over 150. So if you reduce this, you'll get 2. And if you reduce this, you get negative 19. this. Now, I've got it worked. Let me find on my sheet of paper. I've got this worked out somewhere. So I can make sure we don't miss it. It took me about 3 or 4 tries to get this one right again. Not because I don't know what I'm doing, because just little mistakes. I couldn't believe the little mistakes I was making. It was very frustrating. Okay. We're going to forget that we have an equation just for a second, okay? And we're going to take this entire left side and we're going to simplify it down to one fraction, okay? And then we'll take that one fraction and set it equal to 16, okay? So here we go. First of all, we're going to combine these two fractions here. So I have a really big fraction bar here. Okay, I have a denominator of x minus 1, a denominator of x. Now, this is a binomial. There's only one group. Here's a monomial, only one group. So my common denominator is going to be x negative 1. And in between those two fractions, I'm going to put a minus sign because I have a minus sign here. Okay, what do I have extra here that I don't have here? X. And I'm bringing down 3x. So 3x times x. What do I have extra here that I don't have here? X negative 1. And I'm bringing down a 4. Okay, very good. Now let's work on the bottom here. I have a monomial and a monomial. First of all, let's start with a 2. I have a 2 and a 1. What's a common denominator for 2 and 1? 2. How many x's do I have here? 1. How many x's here? 1. So, the most I have is 1x. So my common denominator will be 2x. Put a minus sign between them. What do I have extra here that I don't have here? Nothing, so bring down the 1. What do I have extra here that I don't have here? The 2. So I'll bring down the 1 and multiply it by 2. Alright, so let's see what I have now, okay? Okay, up top here I have 3x squared all over x negative 1, minus, up here I have 4x negative 4. I took my 4 and I multiplied it through all over x negative 1. Down here in the denominator, I simply have, I'm going to go ahead and put these two together. I can do this in my head. A common denominator of 2x. This is 1 times 2 is just 2, so 1 minus 2, negative 1. Okay, so we're cruising along pretty good here, alright? In case I make a mistake and have to come back to this, I'm gonna minimize this in case I need that later. Alright, put that up here somewhere. Oh, should not have done that, should have I? Alright, there we go. Now let's continue on. Let's take our top two fractions and put those together, okay? So I have a common denominator of x negative 1. Now let's put these two together. Now be careful, this negative sign goes to your entire numerator. So I have 3x squared. This positive becomes negative. And this negative right here becomes positive. All over negative 1 over 2x. Now remember what to do. I finally have it down to one fraction over one fraction, okay? So if I have it down to one fraction over one fraction, then I can take the bottom fraction and I can flip it and I can multiply it like this. Let's get rid of this big fraction bar. Let's take this fraction, slide it up here, and now instead of dividing, we're going to multiply. We've got to flip this fraction, so it's really going to be 2x over negative 1, alright? And I can cancel right here, look at this, monomial, monomial. So, x cancels with your x, leaving you with 2. So, 2 times this entire expression would be 6x squared, negative 8x, positive 8, all over. Now be careful. X minus 1 times negative 1, well, that'd give me a negative x and a positive 1. So I took this entire mess right here and I've simplified it down to this. Okay, that's really big. Let me check my notes here. I've not really been watching my notes, which is a pretty scary thing to do. Let's see how we're doing here. Yes, everything is fine so far. So I took this entire mess here, like I said, simplified it down to this. So now what I have is this fraction here equals what? 16. Alright, equals 16. Let's get rid of this. So I'm going to erase this since I know that we've not made any mistakes so far. I don't have to worry about keeping all that, so we're good. So this entire problem has now been simplified down to this. And as soon as you know what to do, it's a rational equation. I only have one denominator, so I don't have to worry about finding a common denominator. Just multiply the entire equation by 1. Negative x plus 1 over 1. Multiply it. This times this. This would cancel with this, just leaving you with 6x squared. Negative 8x. Positive 8. Equals, and now take negative x plus 1 times 16. Negative x times 16. Negative 16x. Positive 1 times 16. Positive 16. Look at that. The entire thing is now simplified down into this right here. Okay, so I have a quadratic equation. Let's get one side equal to 0, and then we can hopefully factor or use the quadratic formula. Okay, bring the negative 16x over, make it a positive 16x. Bring the positive 16 over, make it a negative 16. I'm left with 6x squared positive 8x negative 8 equals 0. Now I can divide everything by 2 to make this smaller, which is a good idea, and that'd be 3x squared positive 4x negative 4 equals 0. And guess what? If you try to factor this, it is factorable. And if you factor it, you will get x positive 2, 3x negative 2. And if you take this group and set it equal to 0 and solve, you'll get negative 2. Take this group, set it equal to 0 and solve, and you'll get 2/3. And both those, you would have to go back and check those two answers in your original equation because it is a rational expression equation or a rational equation. But both answers do check, so they are both correct. Okay, guys. Alright, that's it, guys. I really hope this video has been a help to you guys. If you have any questions, don't hesitate to call or email.